Good morning, everyone, and welcome to my channel. This is Radko Academy, and in this video, I'm going to help you understand even more when it comes to electricity. So this is a topic that comes every year. So if you're writing this year, I encourage you to ensure that you pay attention to this video. And for that matter, if you have not subscribed, make sure that you do subscribe to my channel so that you can be able to receive all the updates and every information from our post. So without much further ado, let's now dive into this. Okay, so when it comes to electricity, the most important thing is you have to understand Ohm's law. So Ohm's law is sort of a beacon of electric current or electricity in short, because all the answers, all the questions are based on Ohm's law. Okay. Therefore, without much further ado, let's now dive into these two questions. So these two questions are very fundamental and they are going to help you understand Ohm's law. So the first question says the internal resistance of a battery is 0.4 ohms and its EMF, that is electromotive force, is 12.0 or just 12 volts. If a current of 2.0 or just 2 amps is being delivered from the battery, what is the terminal voltage? Okay, so now the way you solve this question is just as simple as understanding that. So whenever you're looking at internal resistance, just to give you some clarity, is that when you have a line that goes like this and then goes like that and then goes upward like that. So if you measure the voltage here, let's say point A to point B, in between here, let's say you measure the voltage of 5 volts using a voltmeter, and then now at this point we also now connect sort of a bulb. Okay, we connect a bulb. Okay, so we have connected the bulb to this point. Okay, now if we measure the voltage that is being delivered to this bulb, you find that it is 4.5 volts. Okay, and you find that there is a difference now, or a drop down from the 5 volts to 4.5. So the 0.5 is normally what is called internal resistance, or it is caused by the internal resistance of this bulb. So this is what we mean by internal resistance of a battery. Okay, so that is it. So how can we find the answer? So what you need to understand is that the battery that is found, or the type of voltage within the battery, is called EMF. So what you do is you say E, okay, EMF, okay, equals to the current, okay, the current meaning sort of like the voltage, then plus the I, okay, times the small r. Now this small r is normally what is referred to as internal resistance. Internal resistance of this battery. Okay, and then we know that our capital R is just normal resistance. And then also the we know that I, okay, I is the current. Okay. Now, having understood that, so in this case, they have given us that our R, small r, is 0.4 ohms, and then our capital, our EMF is just 12. Okay, so you can just ignore the 0, 12 volts. And then our current, which is just I, is just simply our just 2 amps. Just ignore the 0. And then what else do we have? Okay, so I think that's all. So from there, we can now just substitute from the formula. So the formula says EMF, which is electromotive force, equals to current times R times plus I, which is the current times the resistance, internal resistance. So we know that the EMF is 12 volts, so we just say 12 equals to capital I is 2 multiplied by the resistance, which we don't know. So capital R is resistance, which we don't know. Therefore, plus, and then the I is still 2 multiplied by the R, small r, which is internal resistance, 0.4. So once we simplify, this is going to be 2r plus 0.8 once you multiply this. Okay. Now what we can do is we can correct the right term. So this 12, this 0.8 will come to the other side. So it is positive to become minus 0.8 equals to 2r. So from there, this is going to remain. So just to help us understand, okay. So to help us understand what you look is just 12 minus 0.8. So we get 11.2. Okay. So 11.2 equals to 2r. So from there now, we just divide both sides. So this goes. Then our R is going just to be. So that number, okay, divide by 2. We get 5.6. So we get now 5.6 ohms. Now what you are looking for is the voltage. Okay, so we are looking for from the question you can see from the battery, what is its terminal voltage. So they are looking at the voltage across the terminals. So this is like the PD, potential difference. So the capital R, we have found it is 5.6 ohms. Okay. So from there now we can say we can now use Ohm's law. Okay. So this is going to be, therefore, the capital R equals to V over current. Okay. So we can just make the V the subject because we are looking for this. So cross multiply. So V, 1 times V is V. Then I multiplied by R, just IR. So from there, now our I is 2 multiplied by our resistance, which we have just found is 5.6. So from there, you're going to get, you're just going to get 11.2 volts. Okay. And that is the answer we are looking for. Okay. So make sure you follow it nicely. Thank you so much for following up. If you have not subscribed, make sure that you do subscribe.